So now we've looked at how to solve a quadratic equation. We looked at solving a quadratic equation with square roots, factoring, and the quadratic formula. But sometimes we're not as interested in solving it as we are just about knowing a little bit about the types of possible solutions to a quadratic function. So we have something called the discriminant, and that is going to be used just to do that, to determine the number and types of solutions to a quadratic equation. So I have three quadratic equations here. So I've taken each of these three quadratic equations and rewritten them in standard form, ax squared plus bx plus c, and then found each of my coefficients and labeled my quadratic terms coefficient, my linear terms coefficient, and my constant term. I've done that for all three of them. In a moment here, I'm going to reveal the solutions to each of them. If I look at each of the solutions, because this video isn't about using the quadratic formula, I've taken out my steps for the quadratic formula and I've squished them down and just put the important stuff in. So if you're going, whoa, where did those come from? I did my work on a separate sheet of paper to do the quadratic formula. When I use the quadratic formula on example 1, here is what I got after simplifying as much as possible. Or I should say after simplifying my original expression as much as possible. Simplifying a little bit further, I got an answer of 2 and an answer of 1/3. On example 2, same thing. I simplified my quadratic formula after putting a, b, and c in. Simplifying it further, I got an answer of -3 plus or minus I times the square root of 5 over 2. Notice that's the same thing as saying, again, I get two solutions, one solution being -3 plus I square root of 5 over 2, the other solution being -3 minus I square root of 5 over 2. So in the first example, I got two solutions, both of which were real numbers. In the second problem, I got two solutions, both of which were complex or imaginary numbers. And finally, in example 3, again, I used my quadratic formula, simplified it down, took it a step further, and got one real answer of x equals 2. So let's take what I gave you up here about the discriminant a little bit further. Not only is the discriminant something that we use to determine the number and type of solutions to a quadratic equation, the discriminant is also defined as a formula. The formula it's defined as is b squared minus 4ac. Hopefully that looks familiar to you. If I were to write out the quadratic formula, so the quadratic formula, which I'm going to write here as QF, it's x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So notice that this discriminant is part of the quadratic formula. And what the discriminant is going to tell us is that if our discriminant, if this piece under the radical here is positive, like in example 1, I'm going to get two solutions and they're going to be real. So I'm going to fill that in to my table. So if it's positive, I get two solutions and they're real numbers. I'm just going to go ahead and say real. If my discriminant, that number under the radical, were to be negative, like in example 2, notice I still get two solutions, but now they're going to be complex or imaginary, however you want to phrase that. So now if it's negative, I get two solutions, but they are imaginary or complex. Oh, and I'm going into the last part of my table, so I'm going to move my 0 over a little bit. And I'm going to say if I get 0 for my discriminant, so in other words, underneath my radical, like I did in example 3, notice I get one solution, and it is considered real. I should move that 1 up a little bit. I get one solution, and it is real. So that's going to tell us something about our number of x-intercepts. So what I'm going to ask you to do is after you watch this video, whether that's in class or at home, I'm going to ask you to graph all three of these equations on a graphing calculator. You're going to graph it in its standard form, so you're going to take this middle piece for all of them, and I want you to see if you have two real solutions, how many x-intercepts you have. if you have two complex or two imaginary solutions, how many x-intercepts you have. And if you have if you have one real solution, how many x-intercepts you have. And then you can fill those pieces in class. It will be something I check for when I check your notes. If you were unsure of how to graph using a graphing calculator, please let me know so I can help you with that. And then finally, let's look at just some examples now. These examples of what we're going to do is we're going to use the discriminant for each of them to determine how many solutions there will be and if they will be real or imaginary. So notice I'm not solving it, I'm just using my discriminant. So on example 1, I'm going to go ahead and use my discriminant, which is the piece under the radical, so b squared minus 4ac. So I'm going to take negative 5, I always plug in with parentheses, minus 4 times a times c. Well, that's going to give me 25 plus 24, which is going to be positive. So I'm going to say 2. So since that's positive, I'm going to have 2 real solutions. On example 2, I'm going to do the same thing. Just want to know how many solutions I'm going to have and what type they are. So I'm going to go ahead and say b squared minus 4ac is going to be 3 squared minus 4 times 1 times 5, which is going to give me 9 minus 20, and that's going to be negative. Since it's negative, I know that's going to give me 2 imaginary solutions, and that's all I'm being asked to find. I'm looking at 2 more examples. Let's start by looking at example 3, and then we'll look at example 4, and then this video will be done. On example 3, notice that I'm not in standard form yet, so I want to change this to standard form first. So I'm going to go ahead and add 25 to both sides, giving me x squared plus 10x plus 25 equals 0. Now I can use my discriminant, because just like when I solve quadratic equations and when I use the quadratic formula, I have to be in standard form first. Ax squared plus bx plus c, and I'm going to go ahead and say b squared minus 4 times a times c. Well, that's going to give me 100 minus 100, which is 0. So I'm going to go ahead and say I'm going to have 1 real solution. Squeeze it in there. And finally, example 4, very similar to example 3, I'm going to start by putting it in standard form. So I'm going to subtract 2x. I'll show my step on this one since I'm going to do both of them at the same time. And I'm going to subtract 3 because I personally don't like to have a negative quadratic term. However, I could have subtracted 8x from both sides, 8x squared. Now that it's in standard form, b squared minus 4ac is going to be negative 2 squared minus 4 times a times minus 3. Well, that's going to go ahead and give 4 plus 96. Since that's a positive number, I'm going to go ahead and say I have 2 real solutions. And that's it. So like I said, make sure you go back in class or at home, depending on what your technology is, if you have a graphing calculator or not, and just fill in, take this extension, what does it mean for a number of x-intercepts in each of those solutions. And again, you can find that out by graphing each of these problems on a graphing calculator. And again, I can assist you if you're unsure of how to do that.